H1 Cao University, and Professor Wu Dongqing from National Zhanghua University Extension, and Professor Wen Hubo from National Zhongzheng University, and Professor Li Dongxing from Shanghai University, Professor Wang Weijing from Zhujun Guanxiao. Okay, next, the student to introduce your group.
Hello everyone, my name is Daniel and I'm here to represent Mingdao Mei. I'm from Taichung, Mingdao Zhongxue. My name is Wang Shenhe, he is Xiang Yu, and he is Diao En. He is Jun Hao, and he is Hong Lin. Thank you.
Next to you.
Hello everyone, I'm Captain Xu from Team Beijing. I'm a teammate, Xing Yu, Zheng Yao, Tao Amy, Tang Shuang. Thank you.
Good morning, honorable jurors and fellow competitors. And today I'm honored to represent my team and introduce my teammates to you. And these are Guo Yongjin, Xu Yong, Xu Yisheng, Zheng Yinxi, and Wang Shenyong. Thank you.
We now start from the challenge of the problem.
We challenge you for question number 2. Ready this.
We like to accept the challenge.
Okay. And write down the full name of the reporter. Okay. Okay, the reporter take it straight.
Honorable judges and distinguished competitors, I'm General Wang Hongli from Dalian, and today I'm going to present to you probability disk. So the first statement here states that this suspended vertical by a thin thread is placed in a acoustic field. This device can be used to measure the intensity of sound by turning about the axis of the thread. Investigate the accuracy of such a class. So the main focus includes loudness and angle, radius and angle, and we define the accuracy as the intensity of sound has to correspond to the angle. So if the same sound can correspond to a more accurate angle with more decimal places, this means that it's more accurate. So this is our demonstration video. So as you can see, the relay set here is supposed to be spin as the main brain started vibrating generates sound. And next week. So phenomenon explanation. This phenomenon is caused by the fact that sound wave is a reflection wave, which means that the air is being compressed longitudinally, and this vibrates back and forth due to this situation. And to fully understand why the disk rotates, we need to apply the torque equation, in which the force will equal to the integral of pressure times delta area, and the area will equal to the integral of 2r cosine theta pi delta r. However, we need to connect the pressure to the sound intensity, as stated in the problem statement. So as we all know, the relationship between sound intensity and pressure is that I is proportional to pressure squared. So applying this situation here, applying this identity here, we can already change. Originally, decibel or sound intensity was defined as 10 log I1 divided by I0. And well, I0 is the smallest human hearable sound intensity, and I1 is any sound intensity that you want to define. And knowing that I1 divided by I0 is equals to P1 divided by P0 squared, we can get this equation. So using this equation, we can further calculate to get that any pressure P1 can be is equal to P0 is equal to 2 times 10 to the negative 5 power times 10 to the power of x divided by 20, while x is the decibel level. So the reason for our last equation is to get the pressure. So now applying this whole thing, seeing that at the axis, there is a torque caused by the string. We call it tau theta. And there is also the force caused by the air vibration, which is we call tau p. So for relating this, W equal to R times F times sine theta, and to inserting all of the calculations that we got above, including the equation for force and the equation for area, and additionally we have the equation for to change decibel level between decibel level, well, sound intensity and pressure. So inserted here. We ultimately got the tau theta is equal to a constant k times the theta change between the original angle here. And at the place, at the position in which the relative stops and indicate the sound level, the tau p will equal to tau theta. Next page. So calculating for theoretical value, we can apply our equation, which is equal to k times delta theta. And the reason for this is that for the string, any changing angle will be linear, will require linear strength with a constant k, which we will calculate later. Applying this whole thing in transitioning, we can know that delta theta divided by sine 2 theta equals to this thing here, in which we will use it to graph our final results. So before we enter our experiment, I will talk briefly about our experimental setup. We hang the relatives very close to the acoustic field, which we will explain later. We have this decibel level there, and we make sure that is parallel. So as I talked about the constant k, in which the tau theta will be equal to k times delta theta. And this can be easily get. As you can see, we have made it very easy, not experienced statistic, collecting the amount of force needed. And the force needed is being measured with a force meter. So the slope of the line will be essentially k, and we can use the k in our equation. So we then go into our experiments. So number one is the relationship between loudness and angle. And our independent variable is the decibel level, and our dependent variable is the angle of rotation of disk. But however, once we measure the angle of rotation of disk, when we plot them, we'll plot them into theta divided by sine 2 theta as shown in our equation. And then the hypothesis is that the louder the sound, the more energy carries, the bigger the waves, and hence louder the sound, the more rotation it makes. And at the right side is our all-controlled size of the disk, shown there. So the result for experiment one changing loudness briefly looks like this. So generally, it seems to fit our trend line. But if you look closely, you'll see two very interesting places. Why is there lacking data at these two positions? And there's a logical explanation for that. So first, let's look at this area here. So when we were trying to measure the area, we weren't able to get successful data measurement. And the reason for that we have investigated is that it's probably because at that level, this loudness is much smaller than the one here. So with lower energy, the air particle vibration rate. I do not mean the sound speed, just the air particle vibration rate, which is affected by the amplitude, and the sound intensity will be slower. So meaning that the lack of energy will cause it to diverge after hitting the relay disk instead of going around it and causing its rotation. So this will be stable, however, the rotation will not be significant. And here, the reason we weren't able to get a data is because this wobbled too much. And the reason for that is the air molecule vibration rate was too fast because of the loud sound level. And there was excessive energy caused the form of turbulence, and the relay disk kept oscillating and wobbling. So that is the reason that there's no data there. Okay, then there is our experiment 2. We investigate the effect of the radius of the disk. So these independent variables are basically the same, except the radius we changed from 0.75 cm to 1.5 cm. And as you look through these data, yes, next page. They might look wildly similar at first, but if I put them all together, if we put them all together, you'll see that for the radius 1.5 centimeters, it has the greatest value for any given decibel level. So what does this tell us about the accuracy of such a device? Well, we defined earlier that the accuracy is how much each sound level represents an accurate value. So the larger, essentially, the larger the y-axis range of this device that it can detect, it means that for a sound level you have a more accurate range, a larger range that can define as for that decibel level. So hence, if this y-level range is greater, there's better accuracy. So from this experiment we get the result that at radius 1.5 centimeters, there's maximum accuracy. And then we have our experiment 3, which is the relationship between the thread width and its effect on accuracy. So previously we talked about the constant K. The constant K may greatly vary between different threads. So we have chosen 3 kinds of threads, which is polyester threads, and cotton thread, and nylon thread. So if I put it all together, you'll see an interesting trend. Well, these are our experimental values, and these are the theoretical ones. Interesting trend is that for the thinnest thread type, which is the polyester thread, it has the greatest Y range. So similar to how we determine the accuracy for the radius, the larger the Y range, the more accurate it is in our definition. So hence, the thinner the thread is, seems to give us a better accuracy. And the reason for that is probably because as the K decreases, as the K increases because of thinner thread, this means a larger range as the delta theta causes a greater increase in torque. And conclusion, so angles and decibels are possibly correlated. Only loudness between 70 and 90 decibels can be measured in our case. And unstable sound flow can cause experimental error. And based on our experiment, we got that larger radius causes larger variation and means a more significant change and hence more accuracy. And in trials with larger radii, each decibel corresponds to an angle that is larger than a smaller radius. So this means that continuous intensity corresponds to an angle and is more accurate. And for smaller radius, it corresponds to a smaller range, so that's accurate. And also we got that thinner thread, there's more accuracy, which is based on the variation of the constant K. And that is my presentation. Thank you for attention.
Okay, now is for the question of the opponent.
Okay, thank you for the presentation. First, would you turn to your experimental setup?
Experimental setup.
Okay, so did you measure the deflection angle using any device? Can you point it out?
Pardon? The what angle?
What device did you use to measure the deflection angle?
The deflection angle?
Is it in this chart, in this graph?
It's not in the chart. So
Okay, we can discuss it later. And would you turn to page 10? What is the unit for the y-axis?
The unit for that y-axis is Newton.
Okay. And what about the x-axis?
The x-axis is in radians, is rotation.
Okay, so do you think that you made an error since 60 and 60 radians is quite large?
I'm sorry, that's probably in degrees. That's just in typo.
Okay, so then by this graph, how can you determine torque constant?
The reason that we are
I'm not sure. You can point it out. The value for
here,
okay. So
essentially the slope of the line.
did you measure the torque constant of other threads as well?
Yes, but we have that experimental value, and I can tell you certainly that the K value is the smaller, the thinner.
So you did measure.
We did measure them.
Okay.
Okay.
I think that is all for my short question.
No, thank you.
Okay, time's up. The opponent takes the stage.
Okay. Good afternoon, honorable juries and competitors. I'm honored to take the opposition today for question number 2, Rayleigh disk. And I would like to start with the summary of the report. And the reporter first started out by introducing the definition for sound intensity, which was logarithmic, which was related to the logarithmic of air pressure. Then he used that, and he also used the diffraction of sound to explain the deflection of the disk. for the reporter's experiment setup, he used, of course, a thin thread and a disc. And in addition, in order to make sure that the sound intensity is a correct value, so the reporter also used a decibel meter to measure sound intensity. And furthermore, in the report, for the report, and for the analysis software of the reporter, he didn't specifically mention how was the deflection angle measured, and I think that is something that we can discuss in the long discussion. And for the conclusions of the reporters, he concluded that first, with a thinner thread, then there should be a greater accuracy for this device. And second, with a greater sound intensity, supposedly there should be a greater deflection angle. And also, the measuring range for the reporter's device was within the range of 7 to 90 decibel. However, there is one conclusion that I'm quite confused about, which was the statement that with a greater radius of the disc, there was always a greater deflection angle. And now I would like to take a look back at the problem statement and discuss the task fulfillment of the report. And first, I think the reporter didn't define the way to measure the accuracy, which means that the accuracy was not well defined. And second, design a device that can measure the intensity of sound, which I think the reporter completed. And lastly, consider different conditions. And for the reporter, he considered variables such as the loudness and the angle of the sound. However, I think that other variables could also possibly be included. And for the strength of the reporter, I think that the reporter gave a detailed introduction for each page of the slide, and I think the audience could all quite understand what he was trying to express. And also, the fluent presentation also add advantages to his report. However, I would like to ask the reporter to be aware for the units of his graphs. For example, the x-axis for the reporter's graph in page 10 should be in degrees rather than radians. And here is another suggestion of mine, which is to answer to the questions of mine more briefly, so that the whole discussion could be more efficient. And here are some of the missing points, and I would like to discuss these questions in the discussion time. Thank you. Okay.
So before we end the discussion, I just want to say that this technical issue earlier, this is the old version of the PC.
Okay.
Yes.
That's okay. First, I would like to ask, how does sound propagate in 3 dimensions?
How does sound propagate through 3 dimensions?
Yes.
You know that it's traveled through different directions.
In different directions.
It's not essentially in different directions. It's sound from the sound source.
Okay.
Spread out. However,
So is sound wave a spherical wave?
is sound wave a spherical wave?
Can we go to the blackboard?
In our so
suppose that there is a sound source. So do you think that the sound propagates like this in 3 dimensions? Or do you think that the sound source propagates like this?
is the sound source unblocked in all directions?
Yes, it's just a sound source placed in the air. Which one would you choose? You could make a guess. We can discuss it. This one? I think I agree with you. Then, based on this concept, I would like to ask you about the derivation of the formula. Could you turn to that page? Okay, next page. So here, I think that the concept in your equation was that the pressure was the same on all points of the disk. Am I correct?
Yes.
So do you think that it is true?
That is the reason that, so previously I said I'm going to explain this. So I said that in our experience we put the disk very close to the acoustic field, and the reason for that is because we assume the pressure is same across the disk based on the assumption and condition that the air
Okay, so
the airflow generated by the
you consider the sound pressure on all points of the disk equal.
because we assume that the airflow is not.
Okay, I understand.
Yes.
So moving on to the next question of mine. So in that case, do you think a greater radius of the disk always leads to a greater deflection, a greater angle?
Greater angle?
Yes.
I don't remember I mentioned.
In your conclusions,
Oh, just turn that on. So a greater radius, greater radius.
Okay. So there is a peak value for the deflection with different radius, right?
Yes.
So what is the cost of that?
The peak value.
Or should I put it this way? If the radius for the disk is smaller, shouldn't the effect of diffraction be more significant?
That may seem true, but according to our experiment, so this actually really.
So you make that conclusion according to your experiment rather than explaining it theoretically, right?
No, so allow me to explain this.
Okay.
So you say that for a smaller disk, the same decibel level perhaps result in a more significant change. But by significant change, if you look at the actual.
Okay, I think I understand your point. So
No.
I would like to move on to the next question.
Okay, sure.
So would you then turn to page 14?
Page 14. Yes.
So you think that the reason why you wasn't able to measure the sound intensity, able to measure the deflection angle was because the energy diverges after bypassing the disk?
Besides that, I would like to mention a losing thing in this PT. As I said, this is the old version. We added Reynolds, something about Reynolds number. So the theory that we want to explain this situation is because that.
Allow me to interrupt. Do you think that energy could diverge? Since I would like to express my own opinion.
I don't mean the energy diverge.
So you're not saying that the energy diverges.
I mean the airflow got diverged.
Okay, so okay, I understand your point. Then we can move on to discuss the next question. We can turn to the page of your experiment setup. Okay, so when the sound source was not turned on, does the disk deflects on its own? For example, if you walk by the device, is there any possibility that the wind that you cause to the device makes it?
So actually this might be a little bit not obvious, but this whole device is encased in a plastic case or container. So when we actually.
So do you have any experiment photos to support your statement?
This is the photo. If you look.
So there's not a container that you mentioned earlier. Right?
It's above it.
Okay.
And it's transparent.
Okay.
And it might not be obvious. I'm sorry for the misinformation.
Okay. Then how did you measure the deflection angle?
We measure the deflection angle mainly by the use of two tools, which is the tracker software, as well as taking a photo.
What point did you track?
We track the initial point, and then we essentially track.
I mean, what point on the disk?
So instead of looking at it from this angle, we look at it vertically, and we track at the horizon, at the edge of the. So essentially, it's originally it's like this. If we look vertically, it looks like this. We track the endpoint.
Okay, I understand.
Yes.
Okay, so, and here's another question. You measured 7 to 90 decibels, am I correct? So did you just put these readings to your experiment results?
Yes.
But I think that because the distance between this and this is different, so I think that the sound intensity level should be different.
I'll agree that to a certain level, yes. But that is the reason, as I was
Okay, so
for that we put the whole device instead of.
I understand. So you think that is partly true, right?
Yes, but we try to minimize the error with the experimental setup.
Okay. So do you think that that leads to error in your experiment?
There may be a small level of error in our experiment due to this, but I believe, as I said before, this is not that significant.
How do you prove that it is not significant? Did you try to place the decibel meter at the same distance between the disk and the sound source?
Yes, we have tried. So
So
essentially,
was the result different?
it's occasionally 0.1 decibel vary, but usually there's no difference.
Okay. I would agree. I think this is a very important question. In my opinion, the sound source in there propagates as spherical waves. And suppose that this is R1 and this is R2. Then the sound intensity level at this given area, I think the sound intensity level should be expressed as the power of the sound source divided by 4 pi r squared. So do you think that the effect of distance is really not significant?
The effect of distance has just shown there. That's weird. Weird. First, but however, we have tested that essentially this is.
Can you show the results of your tests?
We didn't record the result of the test.
Okay, thank you. Then, for my last question, I would like to ask: did you define the accuracy of the device? Yes or
yes.
How?
We say that
Which page?
at the start. Here. Intensity of sound has corresponds to an angle. And the more accurate the angle is, meaning that for a specific sound level.
I'm sorry. Okay. In my discussion with the reporter, I think that there were major flaws in the experimental setup of the reporters. And the first one was that the noises weren't isolated from the device. Because in my assumption, I think that with the thread has such a small torsional constant, so even just a small perturbation could lead to a small deflection. And I think that that has a great effect on the accuracy of this device. However, the reporter didn't show proof that he was able to isolate the noises. And the second question, which I was more doubtful about, was that the sound intensity is supposed to be inversely proportional to the distance between the sound source and the range squared. But however, the reporter mentioned that he directly used the readings on the decibel meter and to serve as the sound intensity of the disc, and I think that is something that might cause great error. Thank you.
As for the result to ask the question.
Well, for both upholder and reporter, I want to ask you both that how do you define the accuracy of the device? Reporter, go first.
We define the accuracy of the device at certain intensity of sound has corresponds to a more accurate angle. So meaning that if, for example, the decibel 78 corresponds to a larger range of angle, it's more
Okay.
accurate.
Okay, got it. And for the opponent.
I think the definition of accuracy is the deviations between the theoretical value and the actual value you measure. So I think in order to define
Okay. And I have seen the reporter conclusion you said that the bigger diameter has the bigger accuracy, right? And what is the most important parameter that affect this conclusion?
Most important parameter that affect this conclusion is as shown in our theoretical equation, the area, because as you can see here, as the radius increases, the increased rate of the final angle will increase. So each change in decibel level will cause a greater increase in angle. So more accurate, yes.
And I want to ask reporter and opponent, if we change the mass of the rally disc, and what will this affect the experiment? Well, reporter go first.
I think this will affect the experiment
How?
by essentially increasing the moment of inertia of the disc, and meaning that the same torque will cause less rotation and essentially decrease accuracy.
And the opponent.
I think that in addition to the effect of moment of inertia, since the mass of the disk increased, so I think that it could possibly extend the thread and thus leading to differences in its torsional constant. So I think that if the mass of the disk is changed, then the torsional constant should be measured for every single mass.
Okay. And the opponent just said that the intensity is proportional to the distance, and I want to ask reporter, if you change distance, what will the experiment happen?
If I change the distance of the disc,
Yeah.
if I change the distance of the disc, well, if I measure the sound level around this again, then this won't really change the result, as in the end, I know the correct sound level at that position and its effect on the radius.
Okay. And for opponent.
On rotation.
I think I agree with the
Okay. And that is all my question. Thank you.
Thank you.
Thanks.
Alright, the reviewer test is state.
Birmingham. I'm the reviewer from Team Vision. And today I'm going to review the problem number 2, ready disk. And the problem statement is about a disk suspended vertically by a thin thread. A thin thread is placed in an acoustic field. This device can be used to measure the intensity of sound by turning about the axis of the thread and investigate the accuracy of a device. And this experiment will focus on how intensity affects the accuracy of the device. And the observation of the reporter is the rotation of disk and vibrates forward and back. And his theory is about torque and the formula that calculates the dB and the pressure, the angle, its rotate and the theoretical value. And his experiment includes materials of disk, different diameter and loudness, and angle and different thread width, and different dB and frequency of voice. And he calculates the constant K and also larger radius. Larger radius causes the larger vibration. And this is overview of the opponent. His speech, brief overview of the presentation, points out several weaknesses of the reports, like the units of scale have more brief answer, and they have the discussion about some propagates in different dimensions, and the pressure of the disk in everywhere is equal, and air force diverging. And their discussion about the thinner, more accuracy. And the reporter says it's related to its angle, and the opponent also agrees with it. And the most critical reason makes smaller radius error less accurate. And the reporter says he used the formula, and the opponent says it's related to its deviation. And my opinion is agree with the opponent. And also, I have asked the accuracy of the setup. And the reporter said his accuracy of setup is about the relationship between the intensity and the angle. And the opponent says it is related to the deviation of the ready disk. And my opinion is agree with the reporter. And easy point is that the reporter ignore the distance between the distance and of the ready disk, and the distance is proportional to the intensity. Yeah, and this is the end. Thank you.
So I would like to give my concluding remarks. So the opponent asked why is 6 degrees that. So the opponent asked, do you think in some way source probably likes to circle spherically? And yes, it's spherical, but since the setup put the disk very close to the acoustic field, we think that it shouldn't really affect the result. And secondly, the opponent asks us, do we believe some pressure on all point of this are the same? And as I said before, we assume that it should be the same based on the laminar flow condition. And the opponent also asked us about the difference between distant will affect the sound intensity level. And yes, there will be a difference, but we believe that there's a very small difference in between. The difference will not be very significant. And we also partly counted it in our error bars. And how do we isolate the whole system? We answer this is a more trivial one. And conclusion, the opponent did ask some interesting problems. However, we think that some of the questions are trivial and already answered in the presentation. and especially the definition of vectors in our case. And the opponent shouldn't grasp on some question that will not significantly affect the actual results. And that is my conclusion. Thank you.
Okay. Is there any question from the jury? Could you turn to page 6, please? The order, page 6. As I remember, you said the opponent asked the pressure on the disk is uniform. Am I correct?
Yes.
Opponent?
I don't think it should be in the case.
Why is that?
Because I think sound propagates as spherical waves, and if the disk,
Well, if the distance is large enough and the size of the disk is small, you can consider it's uniform. So you have other reasons to say the pressure isn't uniform. How about you?
Well, I think I agree with the reporter.
Okay. If the pressure is uniform, how can the disk rotate?
I think that
If you apply a uniform force on the surface, on the disk, it cannot rotate. Am I correct?
I think that
You
is
don't have torque. Without torque, the disk won't rotate. Is that right?
yes.
So what happens since the disk rotates?
I think I have to. I think that since the air particles are actually oscillating in simple harmonic motion, theoretically, so I think that when the air particles hit the disk, then it makes the disk deflect.
I think because it's a sound wave and they have pairs of great compression and lower compression, this variation of compression and the fact that the disk has this distance means that at different
Oscillating, right?
that it oscillates.
So average, according to your point, the net pressure change is still the same.
The net pressure changes may be same, but at
Then it won't rotate.
but at
Okay. Maybe look at this. Okay. Any other question?
I got a question for the reporter. Based on this formula, I think P is the power, right?
P is the pressure.
What? P is the pressure.
P is the
That's
pressure.
is defined with pressure.
Yes.
Okay. And what about as a previous question asked? What was the initial angle of this disk relative to the sound propagation?
The initial angle of the disk is this vertical line.
Normal direction?
That's the worst angle you want to start with your experiment.
If I look at vertically, that is the angle that we
Most
find.
insensitive angle you want to start with.
Okay,
Why is that?
so what about opponent? Any opinion of this initial angle?
Since I think that the angle is defined by the ratio between
Yes.
the length of the arc.
No, all questions.
No, the disk, normal direction of the disk relative to the propagation of the sound wave.
Excuse me.
I mean, just based on this, it tells, I mean, this is in this direction, it's perpendicular. But how about, you change a little bit, make it tilt,
If I make it tilt, then
without affect any,
I think it will affect the results. And
in what way?
if I adjust the angle gradually, then it reaches, the deflection angle reaches a peak, and after that it slowly decreases. Since if we apply the sound intensity from this direction, then I think that this won't even deflect at all.
Okay, thank you. What about
Well, I
review
think
change?
initial angle is really important, so you can change like an initial angle to see what will the experiment happen, and also change the direction of the sound to see the direction of the sound and the initial angles relationship.
Okay, thank you.
Any other? No? All right. Okay. Let's go for the reporter. 5, 5, 6, 7, 8. And for the opponent, 6, 7, 7, 8, 8. And the score for the reviewer, 7, 5, 5, 7, 7. Okay, the end of this session. And we will take a break about 15 minutes. Okay.
跟这个没有关系。
那个是 pressure。
现在关键是说，如果你们的高中物理学的一个物质如果要有配，它的靠它比较的那个作为，如果说你的化是你平常的它这样子，我们中间为什么会有这个事情？如果不有配的话，怎么做这个事情？这个最基本的关键就是为什么有配。
真有，你要帮忙一下。
Long story。这个问题应该是打通过，我觉得各自评的市场应该有。我觉得你们他为什么不有配置不可能？那是因为你们去了解到当我以后因为这个肯定是他的号不是为什么他的号是有讲花了一下。我找你们上课了。
我新的，
你应该看有救了。
昨天给了2包，不是塞了我。
一个人3天，4天。
他们现在过去
对。
懂。那什么？
他的是3天同本，3天同本，我自己看了一下。我也是在。对。他队伍真的不多，他队伍真的不多。
是活动哪一个队伍？
没有，
但是因为他们你那个是高
他们看见习生，
我记得大概5、6个而已，所以差很多。对。
不要受伤。
我们在放空当然知道说大概是，然后我去追究他的意思。因为是也是大家都很多学生，对，但是因为他们有时候自己的处理名称，对，然后就是这个还是因为可能是在训练之初，因为那个他们其实是现在没有长出来，所以他们过去下来都开始看起来是他们是编组，因为有这样跨界的名字，那会在其实从海跟从在边安排各种，它这有时候是设计啊，是那个我们另外一个老师说，哎，你干嘛这样？你要这个他放牌真的是，我说那是牌，没有，他现在没有那么在意这个。不，我知道，如果是动意，他是助理，要变成说，他都有消费者。那个要回到一定会经验，对，但是你，其实他们在传递中，他们我安排不同，都会被对，今天说2个月干啥？其实因为可以去主力那个客家，不是说我是去客家，说这个当然是看电视我知道他们去了3万，我说没关系，那我说公布出来，我说来看这个办公室，谁电视那边你就觉得先做那个动作，然后就跳。我现在是开始在去学这种技术，因为有些一直在调，你不需要就是要这样，然后说一次过去，我记得是，然后在实际上，你们学姐在哪里？你们学姐在哪里？不是看到什么对不对？那个五楼中间有那个饮料跟那个饼干，对。
那个，我想请问一下，就是那个上面的那个任务的提出换过了吗？哦，等一下，下一个场次开始。对，好，那我们先看一下，还是没有办法。就是确认一下我们的提速。这些东西有时候好像没有这个情况，那应该是让我知道。
他没有的，我这样我也是说，如果需要协助，看你没有的时候，你找一个鸡蛋，你不中高阶啊，对，不用上到很高阶了。但是孩子如果有需要，当然我们就是的。但是我互动比较引起他的兴趣跟他的兴趣，因为内容好像是。对了，我基本上就是这个让他们有时候，对，所以不容易，不会让他们做太多。然后我觉得这个像刚刚那个辅导，有一些，他其实我刚刚好像记得有个14分钟的，他时间到之后，他到10分钟，这时候我觉得到这儿还是
他知道你的题吗？
因为我那时候搞不清楚，然后在老师反正没关系，反正他那个筛选是 OK 的，直接是 OK 的。你台师大的大学部，哦，那你们真不错哦，也不需要。 对，现在授课其实没有省分数，是省分多。我记得这一次一个是我们线上授课也有40个学生哦。这个是一方面是学一些东西，他材料的话就需要他，就是好的，那就材料的话，材料就是我记得是初中我那边有一些材料，那个周建生老师，我觉得那些材料都不会太贵，他就是提供一些。然后也是可以去想的问题。你单住宿跟交通省下来不少。是啊，这些小事。对。这个像是。我记得这是一般的。我看谁了？当然我知道是要去做。对对。时间嘛，对不对？我记得是1点半。我看一下我的那个。我这边网。是10点半到12点，1个半小时。
可是我打那么多年。
因为我这边做，我看你如果反转，就是转了20圈好了，你看咋转？你没有帮你，应该这样子20圈转，对不对？
Okay, the competition will start, and now for the opponent, challenge you to order for the rubber.
Problem number 10.
10. We reject. Reject.
Problem number 12.
12.
We reject.
Problem number 8.
Number 8. It's not available. Yeah.
Is it?
No.
It is.
No, it's not available.
不行哦。目前不行。Oh no, we cannot accept this. Okay.
Some questions will be reopened after several questions were rejected. When the total number of questions were down to 5, then more questions will be reopened.
Okay.
Am I mistaken?
现在可以打开。
This afternoon, right, maybe.
可是 number 12被 cancel 掉了。然后刚刚还有什么？然后 number 10也被 cancel 掉了。所以这样已经。Yeah. So the other question can be reopened. Yeah. Okay. Yeah. And number 10 was rejected also. Then it's lower than by question. Okay. Okay. So we can reopen. Okay. So the
we'll accept each other. Sorry.
so the number 8.
Yes. Yeah.
Yeah. Okay. Okay. Great.
Great.
Thank you.
这个规则应该是 OK 的。应该说review的意思是说，上面的题目可以先留掉，最后第5个，那其他的题目就可以再说上来。好像是这样。这个规则你不确定。因为它review的意思，中间那个字的意思是不一样的，所以不然上面要看，所以不清楚。Okay, the reporter and the opponent should write down the full name on the blackboard. Okay, time's up.
Honorable juries and fellow competitors, good afternoon. My name is Wilson Chang, and I'm honored to be presenting question number 8, equal potential lines. place 2 electrodes into water and supply a safe voltage and use a voltmeter to determine electric potential at various locations. Investigate how the measured equipotential lines deviate from your expectations for different conditions in liquids. And first, the experimental setup for this experiment can be easily obtained in high schools. And here is an illustration of my experiment setup, which includes 2 metal cylinder electrodes and a water sink. And for the following presentation, I will denote the difference between the 2 electrodes by the letter D and the water depth to be H. First, for the introduction of this problem, the concept of electric potential can be derived from Coulomb's law, which describes the electric force between 2 point charges. And one thing to be noted, that K in this expression is the Coulomb's constant, and epsilon naught is the vacuum permittivity. So, moving on, we hypothesize that a unit charge is placed near a positive charge. Then, since electric forces are conservative forces, so if an external work is done against the electric field, then we can define the electric potential as the work done against the electric field. And so we get this expression right here. And I would like to note that this formula only works for one dimension. So now we can analyze the situation in my experiment setup. And to simplify the discussion, I approximate the metal cylinder to be an infinitely long straight metal wire. And by adding up all of the integrations due to the small parts of the metal wire, we can get the electric potential due to one single wire. And now we add in the other metal wire, and we consider the linear density of the 2 metal wires to be lambda. Again, by the principle of superstition, we can get that the equation for electric potential lines can be expressed right here. And within this expression, K is equal to the ratio between R1 and R2. So, by setting the value of K different, we can get different curvatures of the electric potential lines. So, I moved on to conduct experiments. And in my setup, I used a DC supplier with an open circuit voltage of 5.93 volts to supply the voltage. And also, I used a digital multimeter attached with metal probes to detect electric potential within the water sink. And in addition, other materials such as electrodes, graph papers, and alligator clips were also used in my experiment. And one thing that I would like to note is that the electric potential within the sink experienced an initial instability. When the metal probe is first put into the water sink, then we can see that this is its initial voltage. However, as time went by, I noticed that the voltage gradually decreased. And I would like to calculate the error that is accounted by this effect. And I noticed that this percentage of error is only 4.5%. And I think this effect can be neglected, so it won't affect the measurement of my electric potential lines. So, for my first experiment, I used different kinds of electrodes, including metal cylinders right here, and a metal ring and a metal plate as each of the electrodes, and third, metal plates. And now we can compare the results I got from this chart. And so we can see that not much deviations can be observed. However, if we replace the 2 electrodes with a metal ring and a metal plate, we can see that there is a significant increase in the voltage behind the metal plate, while this is not the case between the 2 electrodes. And what's more interesting is that when 2 metal plates serve as the electrodes, there is still an unexpected increase in the voltage. And my second experiment was changing the depth of liquid. While I changed the depth of liquid, I also experimented with different electrodes. see how the boundary condition affects. And first, while the metal cylinders served as the electrodes, we can see that simply increasing the depth of water does not give rise to much effect to the distribution of the electric potential lines. However, if we use metal plates instead and we increase the depth of water, we can see that there is a significant increase in voltage again. And actually, we can simulate this difference through console multiphysics. So first I set up the scene and I build up the geometry for this metal plate with the hole in the center. Then I set up the scene for the water where I can adjust the height, which is the depth of the liquid and its relative permittivity. And then I gave an electric potential of 5.93 volts, which was the open circuit voltage of the DC supply. And now, after computing, we can get the distribution of electric potential lines into the console multiphysics software. So now, we can take a look at the situation where the depth of water is 0.3 centimeters. And we can see that there is quite a resemblance in the shape of these two. And here are the results for when the edge is equal to 0.8 centimeters and the water depth is equal to 1.3 centimeters. And the most essential difference between the three results, in my opinion, is that the curvature for these three equipotential lines is different. And in my opinion, I think this is due to the differences in the geometries with this electrode. And for my last experiment, I tried using electrolytic solutions, in this case, potassium nitrate. And after adding such a large amount of electrolytes into the sink, we can see that a rim of unknown substance is formed in the water sink. And furthermore, we can measure the mass for the electrode after each time. As you can see that as time went by, the mass for the electrode gradually decreased. So we can deduce that the substance that is of the color blue is copper ions. And furthermore, I tried to investigate the effect of electrolysis as time went by. And we can see that the electric potential gradually decreases. And now I defined the voltage change at different times, and we list it out. We can see that around the times of 30 minutes and 40 minutes, the change in voltage reaches a peak. Then after that, it sort of reaches an equilibrium as it gradually decreases. So, for the conclusions for this presentation, which includes my explanations for the phenomenon I observed above. First, the voltage decays to an equilibrium state in the beginning, which was the initial instability I mentioned. Second, with one of the electrodes being a metal plate, an increase in voltage can be observed in the vicinity of the metal plate. And in my opinion, I think this is due to the reason that in the edge of the metal plate, the charge density is actually higher than other areas. So when the water depth increased, that also led to differences in the equipotential lines. Third, consider the depth of water. The edge effect or the curvature of the cylinder is smaller than the metal plates. And this means that the charge density in the edges of the plate's electrodes is greater than the cylinder electrodes. And fourth, consider different types of electrolytes. The voltage per 10 minutes changes because potassium nitrate electrolyzes the copper electrodes, which means that the concentration of the copper ions is higher in the solution. And this means that the charge distribution changes, which led to a difference, a deviation, in the distribution of the equipotential lines. And that is all for my presentation. Thank you.
Okay, now is for the question of the opponent.
Yes.
Okay. Did you see a bubble near the electrode?
Excuse me?
A bubble? Did you see a bubble near the electrode?
Yes, I observed that.
Okay. How do you define your zero potential? Because the position you put on the electricity it doesn't have zero.
You mean the reference point?
Yes. Where is your zero potential?
The reference point in my experiment was the negative electrode right here.
So you define the zero in negative electrode?
It is defined by the voltmeter I use.
Okay. All the liquid you use only water or only the
Yes.
All of your experiments you only use water?
Yes.
Do you think the concentration may change as the time goes by?
Yes.
Okay, and this is my short question. everyone. I'm Zheng from Team Vision. Today I'm a proponent of problem number 8, equipotential lines.
here comes to the problem statement, and we may focus on the shape of equipotential lines and the relevant parameters to affect the equipotential lines and the deviation and expectation of the equipotential lines. And it's the overview of the reporter. And in his observation, he introduced his set of the electrical container and direct current supplier digital multimeter to do the experiment. And in his experiment, he thinks the initial instability will affect the time. And the different shape of electrode he used is cylinders and ring plus plates and the planes. And also he changed the depth of water and used the electrolyte. And his analysis includes coolant flow, electric potential, and boundary effect, and also consider the permittivity and the electrolysis in the liquid. And his conclusion is the voltage will decrease to an equilibrium state in the beginning. And the different time of the electrolyte, the voltage per 10 minutes will change. And with one of the electrode being a metal plate, the visibility of the metal plate will increase. And it's the suggestion I want to give him. And his advantage is he has expectation for equipotential line and through the cancel to model. And he do relevant parameters and qualitative explain the phenomena and consider many variables and also consider manufacturers which affect the equipotential line and clearly explain the deviation from the expectation. And the suggestion I want to give is I think because he mentioned the permittivity, so I think she need to talk about more different electrolytes. Conductivity could be better, and I think he should report. I think he should consider the current effects in his report, and he didn't compare the even like the carbon plates and the liquids, and I think compare this can prove his structure. And it's a discussion I want to discuss with him. And first is the parameters. I want to discuss the concentration of liquid affect the line and the different liquids electrode in different positions, also different shape of electrode and voltage. And the theory I want to discuss is the big low and double layer distribution and current density, and then place low also the permittivity. And the conclusion I want to discuss is different liquids and concentration of liquids affect the line. And I want to start my discussion. You mentioned you use the static model, so I won't know because this experiment has current is dynamic electricity. So yes. Why you use the static model to simulate?
I think you made a great point. The console model I used was time independent. However, according to my actual experiment results, it was actually time dependent. So I think that it should be as time went by, several chemical reactions perhaps occur within the sink, and I think that this gives rise to a time-dependent electric potential. And I think if I include more variables in my model, for example,
so you think the time is the majority factor to affect the equipotential line?
Yes.
Okay, and did you consider the current between two electrodes?
Excuse me?
Did you consider the current will affect between two electrodes?
Yes, I think it will also affect because with a greater voltage, then the chemical reactions again the rate of the chemical reactions could increase. And as you mentioned, the theories such as fixed lock, double layers, and other things, these theories involve the concentration of ions within the seam. So, based on that, I think with a greater electric current, it could possibly affect the ions within the seam.
Okay, agree of your agree. You also said you see the bubble near the electron. Because the bubble means there creates gas near the electron. I think the gas has much different permittivity with the liquid. So did you think it will affect the equipment line?
Yes, I think it will affect, and to be more specific, I think it will reduce the electric potential.
And can you predict it will divide the direction it will divide?
No.
Okay. And I think if the bubble creates the bubble only creates in one direction, right?
Yes.
And I think if the bubble creates in the positive electron, and the permittivity will decrease, and because the bubble isn't a conductor, so the line will divide. The line will divide toward the positive electron.
I understand your point. And yes, I think I agree with your opinion.
Okay, and you mentioned the mass of the electron will change. So, how it affects the potential line?
The mass reduced. So I think that all of the mass reduced became ions within one seam. And so I think it is why the color blue become denser. Yes. As you can see, I think there are more and more copper ions within the seam, and it came from the reduced mass of the electron.
How do it affect? How do it affect the line? Can you predict it?
I think I have a hypothesis for that. Copper ions. May I use the blackboard? Suppose that this is the negative end, and this is the cathode. And now copper ions are here, suppose, and I think due to electrolysis, there will also be this sort of ion. So as time went by, the ions that are formed around here goes to this side of the electrode, and the copper ions go to this electrode. And if the molecules right here attach to the electrode, and these attach to the electrode, then this might shield the electric potential and thus lead to a drop in the electric potential.
So I want to know is the shape, how to change the shape. So it will develop more elastic, or it just develop will be like this, or as like part of the ion would the line will be developed more elastic, or just maybe not very smooth.
I think that it will be more like this, because the distribution of the ions are not uniform. Or I think it is nearly impossible for it to be uniformly distributed.
Okay, because the liquid is not uniform, so you consider if you use the current lens to do this experiment, then it will
I think I agree with your opinion.
Um, because you know the time will affect the result, so do you have the better solution to create it, or you just can?
I think I can only record the electric potential when it reaches an equilibrium.
Okay. And so when you measure the potential, you put it for a long time to draw a potential, or
Yes.
you just okay. And you use it's a direct current. So I want to know if you use the alternating current, it can draw a line or it's not.
I haven't tried using alternating voltage, but I think that it will cause a different result for the electric potential. But I don't know how it affects, to be specific.
I think the alternating current can draw the equivalential line because because the voltage in the liquid is always change. So I think it cannot draw the equivalential line. And also the ion in the water not went to the negative or the positive electrons. And because the digital multimeter have a resistance, so you think if you put a probe into water, it would affect the equivalential line?
Excuse me?
Digital multimeter have resistance, and if you put the probe into water,
Yep. I think the resistance of the voltmeter is quite massive, and as far as my knowledge goes, it is often, for example. And if you use a bigger container, it will affect your line, because I think your ion. I think the boundary condition affects.
So you think the boundary affect because of you see. And do you use different?
All right, nice up.
In our discussion, we discussed the currents affect the line or not, and if the bubble could affect the line, and the reporter's answer is it would affect the permittivity, so it would affect the line. And in my opinion, I also agree with him. And the time, he mentioned the time would affect the results, and because of the electron, the time I also agree with. He said because the time would affect the results, so he will put a long time and then to draw the equivalential line. And I also agree with his point. And because I think first the ions is not even, it's not uniform.
Okay, nice up. And next for the H.
Good evening, dear honorable judges and the delegates. I have any questions for both the recorder and the opponent. So we're going to have some expectations or hypothesis rather than the theory, since the program statement stated that you should provide some expectation to how the experimental line will change. Yes or no?
Yes, I have expectations, and
Okay.
I think
Do you believe that the reporter actually provides the expectations for the results?
I think he has the explanation, but I think his
Okay,
explanation
thank
is
you.
not very.
How would you describe the curve of the exponential line? Is it
I think I
hyperbolic or
use
parabolic?
an equation to describe the electric.
So is it in the characteristic of a hyperbolic or
I think it's not a hyperbolic because,
so
as you can
believe
see in the
it's
chart, I
hyperbolic.
think this curve
Okay,
is
thank you.
both.
Do you think the curve is a hyperbolic or a parabolic? Or parabola?
Pardon?
It's okay. Have you considered whether using AC or DC would affect the asymmetric
No, I don't think, and I haven't considered that because
Okay.
I think with alternating current, there will be difficulties in measuring the electric potential.
Do you believe the products of the electrolysis will affect the results?
Excuse
Yes
me?
or no? Do you believe that the products of electrolysis will affect the results?
Yes, as I just mentioned in my presentation, I think that the
How
ions that form in the water
about the
state.
physical properties?
Could you let me finish my question? I'm sorry.
I need short answers here.
Okay.
Yeah. So do you believe that you should consider in the electron double layer theory since you have a change in your z-axis?
Yes, I think I should.
Sure, yes or no? Yes.
Yes, because
Okay.
I think that if the ions adhere
Okay.
to the electrodes, then I think it will affect the
Okay.
electric potential. In my discussion
So,
with the
I
reporter,
want
I
to
think that
next one.
if it shows the electric
in
potential,
in your
it will cause a
theoretical
difference.
calculations, you did not take into account for the width of the electrodes because since that your electrodes do not hold a constant charge on one point, do you believe that there will be a correction for your theory?
Yes, and as I've mentioned, since according to your hypothesis for the electric double layer, an increased contact area,
This is not the double layer question.
I think it is related to the electric double layer question.
This is for the electric potential equation.
Yes, and I think the electric double layer
Okay,
would affect the electric
do you think
potential.
the theoretical calculation needs correction?
I think yes.
Okay, thank you. So, do you believe that since there's different charges for the electrolysis product of H2O, do you believe how the shift of the products of the different charges will move? How would you describe it?
I think, as I've mentioned in that, but
Okay, time's up. Okay.
Okay, so Hi, I'm the reviewer from Dalian. I'm going to review for problem 8 potential lines. So first, the problem statement, as mentioned, we believe the main focus of the problem statement should be the electric potential at various locations and the deviation from the expectations. So sorry, the reporter provided some theories. It's the Coulomb's law, which accounts for the electric force, and the electric potential equation, which only works in one dimension, and it accounts for the work done against the electric field. And there's also a theoretical analysis of the electrons. And the relative parameters that they considered in the experiment was different electrode and depth of the liquid, and using a different electrolytic solution, which we believe that this wouldn't be enough for the explanation and conditions. An overview for the reporter. Some advantages is that they have a well-structured presentation and overall logic and throughout presentation. And the theoretical value was presented, and they provided the simulation value. And some suggestions is that they did not answer fully on the problem statement since that they didn't provide enough conditions, and they need to explain some the reason behind the decreasing voltage or unexpected increasing voltage, since they only describe how it changed. And their error of 44.5% is really high and should not be neglected in the experiment. And some of the units on the graph are missing, and they could consider more parameters, since the problem statement stated that they need different conditions. And they didn't specify the concentration of KNO3 solution, which the concentration of the KNO3 solution would affect the electrolysis rate. And they should also include the method of obtaining data, because they did not specify how they recorded the data under or above the basin. And so they also did not consider how the products would, the concentration or density of the products would affect the resistance in the whole system. And they didn't consider the effects of how long the experiment lasted. And some overview of the opponents. They get some interesting errors and a good summary. And there are also some important points that is missed and didn't catch the mistake in the theory. And discussion 1, like why did you use static model? And they could discover that it should be time dependent. And so we believe that you also need to be time dependent. However, the reporter's report did not show how they controlled and considered time, which I do believe that this is one of the important parameters. And so the opponent asked, have you considered the effect of bubble? And the reporter said that it would decrease the potential. We believe that whether it decreases or increases can be identified, since the reporter didn't do any experiment on proving that, and that is a broad statement that shouldn't be made. And the opponent asked, how did the ions created through electrolysis affect the equipotential lines? And the reporter answered that they showed the potential, decreasing the potential. However, we believe that this question is quite trivial, which shows the lack of understanding of the problem on the opponent's side. And they asked, what do you think will happen if you change the alternating current? And so we believe that the change of alternating current will provide a symmetric the distance on the left and right side, since the charges are always changing in positive and negative side. And some points missed that on the opponent and report side, they didn't accept the effect of the time in the experiment. And they did not follow the answers to the problem statement. And they didn't consider other conditions, and like changing DC into AC or other solutions. And there are a lack of correction to the theory, as multiple errors were made, since the electron notch has a width and the point is not the constant, so the distance that is used in the theory was different. Thank you, and this is my
Okay, the concluding remark of the reporter.
First, I would like to thank both the opponent and the reviewer for raising very important questions regarding my research. And first, the opponent raised questions regarding whether the model was time dependent. And I replied that since the model was time independent, so I think there wasn't a great match between my theory and experiment results. And I think that it is a great point. And furthermore, I also discussed with the opponent about the possible products of electrolysis, and such as the ions or the gases. And I think I was inspired by the opponent that these products could also give rise to differences in electric potentials and even deformations of the electric potential lines. So, and furthermore, I think I also got suggestion from the opponent, such as using carbon plates, or to consider the boundary condition, and by changing the size of the water sink, I could change the boundary condition, and I think that was a great point for investigation. And as for the reviewer, I think that the reviewer also pointed out many major flaws of my experiments, and however, there are several points that I would like to justify. And first, in order to measure electric potential, there must be a certain amount of electric current that flows through the voltmeter in order for the electric potential to be detected. So, for example, when I used oil, I wasn't able to measure the electric potential, and that was the reason why these sorts of liquid wasn't used. And I think that several highlights in my experiment included, first, I compared the results, and I found interesting results in the deviations in electric potential, which was retired by task. And there was a great combination of chemical reactions and physics.
Okay.
Thank you.
Is there any question from Jerry?
The presentation 19, please. You have 5% decay. It's pure water. It's tap water, right?
Yes.
You use tap water. Could you explain why you have this 5% decay in voltage?
I think that this deviation is because I have to admit I don't have quite a physics concept for this phenomenon, but I think it is related to the distribution of the ions. And
what ions? What's inside the tap water?
Since I use tap water, so there could be many unknown substances. And
But what? And what's the? I think you can actually estimate the concentration of what you call the impurity.
okay.
Then to describe this 5% difference. So I really don't know the answer. I just want to know. You know the answer. Could you turn to page 23? Yes, behind the plates, the two electro plates, we measure 6.65 volts. It's greater than 6 volts, right?
Yes.
And you said because of the ion concentration.
I don't think it is due to that concentration because.
Oh, you don't think so? Okay.
Yes.
Then why you have a value greater than 6 volts?
I think that it has something to do with the differences in the charge density on the metal plate, since its geometry.
You mean the metal plate has different charge density?
For example, on the edges, the charge density may be greater than on the areas.
But you look in the middle, on the right-hand side, in the middle, it's far away from the edges, right? And you still measure 6.65 volts.
Yes.
Then why? Okay, opponent, do you have the answer? How about the reviewer? No, that's okay. I don't know the answer either, so I just want to know. You know.
So any other question?
I have a question for here. So do you think that we'll have, do you change DC to AC? Because you mentioned that they don't do this. But do you think that will help?
I think the whole potential line arrangement will be asymmetric from the middle line.
Yeah.
Because the AC is alternating curve, so the truck and the data line will be alternating. So I think using AC would be more accurate in obtaining the data. It is.
Really?
This is the finding in our experiment.
I think I have an opinion for the alternating voltage, since as its definition, the voltage is already alternating. So
Yes.
I think it wouldn't be quite meaningful to measure the electric potential in that case.
I also think the alternating current cannot measure like equivalential line because the voltage always change and it's hard to measure. I think.
So I will correct that is that yes, there will be a change in the voltage in the points in the system, but we do this experiment in order to answer the problem statement that we have to measure different conditions. So I think this could be one condition that we have to measure and make our expectations. And the arrangement of how the potential lines were also quite interesting, since that it makes this asymmetric arrangement in the potential line.
May I ask something? If you use a multimeter in the DC mode to measure our AC plug, what do you get?
I think there is also an AC slot, and
No. You use DC mode because what you are measuring is actually DC mode, right? When you use DC mode, you multimeter to measure the plug on the wall. What value do you get?
then the readings will be alternating.
What? Try it when you go home.
Okay, thank you.
Okay.
Let's go for the reporter. Okay, 6, 6, 6, 8, 8. And then let's go for the opponent. 5, 7, 5, 6, 7. And the score for the reviewer. 8, 7, 5, 6, 6. Okay. Thanks for this session, and we will take 15 minutes for the next session.
这个是常识，因为我这就是比较。
而且这个其实这个想法也是我们当时在看。
所以你说AC 去量了 ，DC 量的治疗是要 DC 梦
需要帮忙的。
原来人家讲说，如果你这个时间的 DC 不能做，你什么搞？课里面，我这个课告诉你，因为我是用 DC 梦去分析，你这样找到 AC， 对不对？你看量这个我们家里的电压的话，你的 load 有多少 AC 才能高？他刚刚讲，瞬间或者 DC 梦讲的就是没有错的，所以我要帮问，如果说你这个实验要 AC 去做，你不做，你把那么多事情做，对他们对称。
对啊，刚刚跟你差不多5分钟。那休息还有时间，可以。因为你们的这里面那个看起来有点正面的。力气也不一样，所以你做出来是跟他不认识，但是跟两个要求的你要去抓好不一样的，所以他才改变你。我可以看你再找一下。没压力了。
简单讲就是，人家问到那个问到比赛，好像是95开头，好吧？
这个几点？这什么时候开始？好，那5分钟。
中间就
较急，他说休息5分钟就好了。
然后当然他们规定说，
女生。
哦，然后看到5分钟，5分钟好像不太够，就说换成10分钟，还是比较少。
到都很有趣，都是之前没有考虑过的。
谢谢。那个就是，如果你以后有空，我是觉得就是如果你觉得它很奇怪的话，然后你把它连接掉。
不是。这边几天有没有遇到什么比较强势的对手，或者是？
没有协同，协同一对，就是靠那个水桶一对啊，然后他们那个时候是在，他们是报3面赛，他们就是很多那种模拟的线。然后他们常常讨论会不会铝棒，然后没有报。
我跟他们对到他们报那个波3年来是对，然后我就享受到了第一次被8个老师当成轰炸的感受。对，可是我觉得他们就是有一些回复都很自私，就是
我觉得他们应该是练过那个回答。
对，就回答就是长这个样子，不然就是当opponent的时候就是不跟你问这些问题。
其实学运的话，我在看看我去的，哎，差不多。差不多，这个在测什么？
真的，因为导师特别提醒我不要，就是有时候不要压下去啊。第一次做这种太强势的事情，所以就没有压。但对啊，我觉得很合理，因为 review 本来就是要掌握时间。然后刚才当opponent的时候也有，就是太过刁钻。我后来想起来一下，有很多。对吧？教授看起来反应也是，就是问的问题其实都没有问到点，都是在钻一些小细节。
好像我一画完一条线之后，然后再设计 S， 我就感觉长得不太一样。我就画一画很久，然后就都没画出来，所以画出来是真的很对称。
有没有距离？
有没有距离线啊？那个就是 DC 转 AC 那个是。
就只是说可以用的。
还好。
现在在外面请假。回去找他，回去找他。
他们都叫电位线，还是那个区位。
因为我们的 expectation 都是理想的状况，所以说可是我们实际上做实验的时候，你就看到其实跟理想状况不太一样，就是
对，你应该可以符合这个度。
因为我们那个很为数，它可以考虑到很多我们实验上会比较
The releasing was started and the opponent challenged the water quality problem.
We'd like to challenge problem 7, which is 3-sided dice.
please write down the full name of the report.
from imaging. I'm going to report from another cabin, three-sided dice. That's the problem statement. To land a coin on its side is often associated with the idea of a real object, but the physical and geometrical characteristics of a cylindrical dice show that it has the same probability to land on its side and one of its faces. So we define the probability of landing on head side 2 is 1 to 1 to 1. Thus, we mainly focus on what's the dimension of a fair cylindrical dice. I'll talk about the analysis, experiment discussion. That's been the conclusion. In this video, we can see the dice fills and rotates at the same time. And early on, it will come to a steady state and land on its side. First, when the dice fills down, when the dice hits the table, the normal fills and the weight will give you a trick and it starts rotating. Because the collision, as in the elastic collision, there must be the energy loss. So finally, the kinetic energy of the dice will come to 0 when it's smaller than the torque from the weight. The direction of the dice will depend on the relative position between the barycenter and the contact point. And that is dice circumscribed as sphere. That's the lab picture. This dice has the ground with the right curved surface. The barycenter is on the left of the contact point, and it will flip to the left and then on the face. And in the middle picture, we can see the barycenter is on the right of the contact point, so it will land on the side. According to this mechanism, head, side, tail has the same probability to land on the floor. So we can get that the curved surface area should be the same. But how to calculate the curved surface area? According to Archimedes' method, the spherical cap area equals the lateral surface area of the cylinder. First, we define the thickness of the dice as T and diameter as D. And the dice is circumscribed as sphere with a radius of R. Then we can calculate the probability of landing on side by equation 1. And also the probability of landing on head and tail by equation 2. Thus we can get for the fair dice, the thickness to diameter ratio equals 0.353. But when the dice is too thin, the tip over angle that here is smaller than 45 degrees. We should take the tip over correction into account. As this graph, the first graph shows the dice land on the face, and the edge is the minimum of every stage. Then, if we with a rotating angle theta, and we can calculate the edge by equation 4. The edge changes as the difference theta and beta. And then in the shear state, when the barycenter is directly above the contact point, the edge is the maximum of every state, also equals R. And in the last picture, when the dice falls down on the side, the height is smaller than the shear state. So that's the right graph. The y-axis is the height of the center of mass, and x-axis is the rotating angle theta. When from the first state to the third state, the height of the center of mass increases. However, when it's on the side, it decreases. And vice versa, from pi divided by 2 to pi. And let's see the graph. The y-axis is the potential energy of the center of the mass, and the x-axis is the rotating angle theta. However, when we calculated the potential energy of the dice, we should both consider the mass and the height. So we take the mass into consideration and draw that figure. So when it is in the red part, it will land on the face. In the green part, it will land on the side. And if the dice would like to bounce and turn to another state, for example, from face to side, it overcomes this potential energy as the green delta as shown in this figure. And we can see that the bigger the TD ratio of dice is, the bigger the potential energy needed to close. However, if you want to flip from side to face, it should overcome this potential energy, and as shown in the red delta H. And we compare the difference of the green and red line of the same TD ratio dice. We can see that bigger the TD ratio dice is. We can see the smaller the TD ratio dice is, the easier for the dice to flip to the face. So I can get this figure, and I examine my data, the axis, actually from the x-axis to the sine beta, and we can get the linear relationship between the probability of landing on which side with sine beta, and we find the value sine beta equals 0.334. However, when the thickness diameter ratio equals 1, as the beta equals 45 degrees, the delta H is equal, so that they didn't need a tip over correction. And in my experiment, we do two experiments for the coin set and the copper stick in different sizes. First, for the coin set, we use the TD ratio from 0.16 to 0.96, and this is the first 100 kills. We can see that our square value is about 0.9783, and when it comes to 200, it is bigger. And comes to 300 kills, the R square equals 0.9969. So we toast each coin set 300 times with a cap to make a random toast in our further experiment. And this is the result of our experiment. So we found when the probability of landing outside is 1 divided by 3, sine beta equals 0.301, and as the TD ratio is 0.354. And for the copper stick experiment, we use 11 copper stick and toast each copper stick 300 times with the cap. And the copper stick, we find the ratio as, we find the sine beta is 0.377, and the thickness to diameter ratio is 0.307. Then we compare the copper stick and the coin together. We can find that the probability of landing on side of the copper is bigger than the coins. And we think that might be the transfer factor like this. The probability of the coins to land on side would be smaller than the copper stick to land on the side because the transfer, and that increase the face down probability. So we can compare our experimental result with the theoretical value, and we can see with our experimental result as lower than the theoretical value. At this point, it's 45 degrees. So that is, we previously see it didn't need a tip over correction. So that cruise at this point. And we can get a linear relationship between the probability of landing on site with psi beta, like equation 5 and 6. And this is our experimental result and the theoretical value of the psi beta and TD ratio of a fair cylindrical dice. For a fair cylindrical dice, we make a copper stick with TD ratio is 0.307, and when we toast 550 toasts, the psi probability average comes to 33.5%. So we can see the ratio is near a fair cylindrical dice. And it's my conclusion. First, for fair three-sided dice, the thickness to diameter ratio is near 0.307. And the probability of landing on site head tail has a linear relationship with psi beta in the range of our experiment based. Yes. And third, the probability of the dice is not only affected by the landing direction, but also the dumping. The tip over correction must be taken into consideration. But when psi beta, and that is when psi beta is under 45 degrees. And as my reference, thank you.
Honorable judges, this is the opponent from Team Mingdao Mei M. And so I have some clarifications to make first. So I'd like to ask, have you considered friction in this system?
Yes, it could cause the energy loss.
Oh, okay. Have you considered the change from spinning energy to potential energy?
Yes, it is mentioned in my potential energy.
Okay. So you did consider both of them. Okay, good. Would you say that the release of the dice is a random motion?
Random motion. Oh, we use the cap to make the random condition.
Okay, so it is being kept as random. Okay, that's good. How did you make the dice that you use in the experiment? Did you 3D print it or?
The copper string is just.
So basically stake a lot of coins together and also copper sticks together.
Basically, yeah.
Okay, good. So what are some geometric characteristics or physical characteristics that you've observed? Because the problem statement asks you to basically investigate.
That's my physical characteristic is in this video, and it repeats them together and the collection.
Physical characteristics basically mean the physical requirement of the coin for it to have the same probability to land on your dice. So I believe that is something that we can further discuss later on. Okay, so we'll move on. So what have you considered how you initially toss the dice? Because you said that it is random. How do you make sure that when you're tossing the dice, it is also always kept at random?
Oh, we cannot really make sure it is random. But
so you basically just use your hand and drop it down?
No, we use a cup to check it and drop it.
Oh, so you shake it first and then you pour it down. Okay, got it. Okay, and I believe that's all I have. Thank you. Okay, I'm with juries, and this is the opponent from 8 到 M. So first of all, I'd like to make a brief summary of the reporter's performance. So first of all, I'll start with the problem statement. So for us, we believe that the main focus should be the constant probability, and we believe that the reporter should also consider stating out the exact physical and geometric characteristics of a cylindrical dice. The summary of the report, so basically the theory that they provided was the probability calculation, which include head, side, tail, or the same. And they also includes the theory of Archimedes' spiral and also the tip-over correction. For experiment setup, they use three-sided coin and drop it, and also copper stick as well. For parameters, they changed different coins, copper, and also copper sticks that were staked together. And for the data, they provided both theoretical and experimental data. So some advantages for a reporter. So first of all, overall well thought out presentation, so explanation is very clear. However, some suggestions would be that theory explanation was a little bit too long. I think most what the problem statement asks is more on the experimental side. And second, did not have enough parameters, for example, mass and even the drop height or the initial speed, which should also be always be considered, and did not consider the collision energy constant. And the friction force was not integrated into a theory, and should not use the glue to connect the copper as it creates an uneven distribution of mass. For the setup, she shows a clear video. However, suggestions will be that not clear on how the dice was thrown. Use a clock to throw, because as we all know that when we use the clock to throw the dice, some other parameters would also change as well. For example, the speed. For their theory, good theory deriving. However, they didn't consider collision energy constant, and they also didn't consider the friction created by the sliding motion of the coin. For experiment and data, some advantages would be that they have clear data and graph. However, some suggestions would be do not have enough parameters, which the problem statement asked for, and they then consider the average of TD ratio because it was only at a small range, and they didn't show how the experiment process is conducted. So, some points that were missed. Some points that I will be discussing will be first the friction, because we believe that some friction was not considered, and also the surface of the ground wasn't really defined clearly, because it seems like the theory, the condition of the ground in their theory differs a lot from their experimental surface, and also their experimental setup has a lot of questions in it, which I would like to clarify and understand more to come up with more questions. And so I'd like to start the discussion right now. Okay, so first of all, like what I just said, I'd like to start off by clarifying some things. So first of all, so you define the friction. Can you please go to that page? The page where you. Okay. So what is this friction acting on? So what is the two things that this friction happens? What are the two things? So are you saying it's the friction between the coin and the ground? And what causes that friction? Is it making it spin? Because okay. So let me say my sense. Because I believe that when you're considering this entire motion, the friction between the coin and the ground has two different sides. And one of them is the friction when it is sliding, because we all know that probably you've done it yourself. In your experiment, when the angle of collision with the ground is at a very small angle, it's very likely that the coin will slide a bit. Have you considered that in your
Also, that's the friction of the dice. Like there is this direction, and then floor will give it that direction friction.
So have you made a correction on it? Probably because it doesn't seem like your theory contains a part where the slide motion happens. Okay, never mind. I'd like to move on to the next question. So, how would you describe the surface of the ground in your theory? So, for your theory, what is your assumption for the ground in your theory? Is it a rigid body, right? Am I mistaken?
No, a material is hard.
No, I mean in your theory.
Hard.
Oh, it's hard?
Hard.
Hard ground?
Hard ground, yes.
So is it a rigid body or a non-rigid body?
But it's a rigid
body. Okay. So for example, in your experiment, is what I'd like to ask.
Mouse mat.
Oh, it's a mouse mat. So definitely that's not a rigid body, because when a dice falls onto it, it basically deforms. But from what I've seen from your theory, I believe that your theory is probably based on the fact that the ground is a rigid body.
Yes, actually I agree with you. And I think there must be some deformation and the mouse mat. So I think it might be the deviation between my theory and my experiment.
Yeah. So would you please go to a part where you compare the two theoretical data and experimental value? Then why are the data so accurate between the two? Because your theory is considering that the ground is rigid body, which is probably impossible in real life. But in real life, you're using a non-rigid body. So since the theories are different, are a lot different from the experiment. So how is the result still that accurate? Do you have an explanation for that?
Oh, first I think the smoothness of the mouse mat could lead to the value of our experiment smaller than the theory. But the tree as the same.
I'm saying why is it so accurate? Because your theory doesn't seem to match up from your experiment. Because this seems very, very accurate, right? Yes. So I'm wondering if your theory is probably mistaken. Yes. So I think that's another part that you can probably consider in the future. So I'd like to move on to the next point. So in the problem statement, we know that the experiment requires us to consider different conditions. But I believe that some of the parameters weren't controlled. For example, the drop height and probably also the mass. Have you considered what the mass will have on the entire probability of the dice?
In our experiment, we use mouse mat to do the experiment. So if the mass of the dice is bigger, the deformation will be bigger. So I think it would make a bigger deviation from our theory. And as for if the mass of the dice is too small, and if the dice is still think it might.
I'm not saying about the thickness or the width. I'm just saying the mass. If you're considering that, so just make this assumption: the width, the radius, the ratio between the angle and the surface are all the same. You're only changing the mass. You're only changing the mass. Will the probability change if you only change the mass of a coin? This is basically a yes or no question. Do you think the mass will affect the probability? Mass.
Yes, in
so
reality.
Yes. But what from my point of view, I personally believe that the mass doesn't really change the probability because we all know that. So let's see. So here's a $5 coin, and we all know that $5 coin differs in mass with a 50 NT dollar coin. But when you drop it, we all know that the probability is always going to be 1/2, right? No matter for this mass or the mass from the 50 NT dollar. So do you believe that the mass still affects the probability of the dice?
I think it should affect in every.
So you still think it should affect?
In every situation.
Okay. Then what about the drop height? Have you considered the drop height?
No, because we just made a random condition to drop it.
Oh, okay. Yeah. So I believe this is the part that you got wrong. And you got right, because drop height doesn't really affect the probability, so that's good. But mass, however, should make some improvement on that. And I'd like to ask, so the way you throw, can you please demonstrate the way you throw the dice to test the probability? Okay.
It's a slow move.
Okay, so you right here, you're just shaking it.
Yeah, just
and you just let it go.
Yeah.
Then is this initial velocity 0? Because
no.
So this is not 0.
No,
the initial velocity is not 0. Because normally I think
sometimes 0, sometimes have some angular velocity.
So sometimes it has velocity.
It's a random condition.
So you're saying that the angular velocity might change, might be different when you're dropping it, right?
Yeah.
Okay. So from my point of view, I believe that when you're shaking it, it is quite a lot different from when you're dropping it, because when you're dropping it, the initial velocity is basically 0 because you're not applying any force to it. But however, from shaking it and then giving it a force to release it.
We didn't give it a force, we just moved it.
But how do you make sure that when you're releasing the ball, releasing the dice, you did not shake to the shake? So that's something that you couldn't consider.
Yes, if the angular velocity, if the initial angular velocity did really affect the result.
I think the initial velocity will definitely affect the result, because from your own theory, the initial velocity should be 0, and I believe that's something that you should probably control.
Please, I want to.
Oh, okay, sure.
In our theory, we can use the theory and the last we found when the kinetic energy is equal 0. So just as you see, the initial angular velocity is the initial condition, but our theory is based on the last condition.
Okay, I think this discussion is pretty much expired. I'd like to move on to the next one, which is on how did you stake the copper stake together?
Just use glue.
But then I believe there's one problem with that, because yes. Do you make sure that the mass are evenly distributed?
No, we cannot really make sure that.
Okay.
Yes, but we.
Okay, I can give you probably a suggestion that you might consider, which is probably 3D printing a dice instead of having to stake them all together. Probably, that's just something that you can do. And my next question would be that, so what should be the physical characteristics? Because I didn't see it in your conclusion. Physical characteristics. For example, the ratio between the radius and the height of the coin or something like that. So you only consider the thickness to the diameter.
Yes, based on our experiment of the copper stake.
Okay, that's good, that's good. What about So this is the geometrical characteristics. But what about the physics one?
The physical one is the damping Typt orbit angle.
Okay, so from that, I believe that is a little bit insufficient because when you're describing the physical characteristics, I believe that the coefficient of friction might also be in the physical characteristics. So you might have to measure the coefficient of friction for every dice that you make, because the coefficient of friction definitely affects the friction, like what you just said, because the friction definitely affects the probability, right? Yes, right. Okay. I believe that's the end for our discussion. And I now like to start with summarizing what we've just discussed. So I believe let's just start from the very beginning, from the problem statement. So we believe that there's some misunderstanding by the reporter on the problem statement, because the problem statement clearly asks to describe the physical and also the geometrical. They've done well on describing the geometrical, but I think for the physical characteristics, there might be some addition that can be made to it. And as for the experimental setup, I believe that some of their experiments are deeply flawed. For example, the shaking of the cup and then releasing, which might create a different initial velocity. And then the way they stick it, the way they stick the coins together might also be another problem. Another problem would be that the surface of the ground in their theory and their experiment are different. So I'm wondering how they could be able to predict their experimental value through theoretical value that is basically wrong, because the two surfaces are not the same. Yeah, so that's basically the conclusion. Thank you.
And then for the reviewer for the question.
Okay, so my first question is for the opponent. You mentioned that you believe the problem statement wants the reporter to find a dice with constant probability. Is that correct?
Yes.
Yes, but you also mentioned that you believe many of the physical characteristics affect the result of the dice roll. So how would you find a constant probability if there are so many parameters at work, and so many parameters that could affect the result of the dice roll?
I believe there's a range for physical characteristics. For example, from what I just mentioned, the coefficient of friction. I believe there's a certain degree of coefficient of friction that will create the even distribution.
Do you believe that the characteristics of the dice under that range, the different points in that range, would be exactly the same?
Can you please rephrase?
You mentioned that there should be a range, correct? So do you believe that in different points in that range, the characteristics of the die would be exactly the same, constant?
It's the difference in value, in numbers, not the points.
A number of values of what?
Number of values, for example, from what I've just said, is the coefficient of friction. So I'm not sure what you're asking.
I'm asking, do you believe that under the different conditions in the range you mentioned, would the characteristics be exactly the same? For example, if the coefficient of friction is 1, and if the coefficient of friction is 2, would the other characteristics of the dice be exactly the same for these two conditions?
It depends also on the mass and also the height of
so it's not a constant probability.
So you'll have, it is a constant probability, but you have to first make sure that your geometrical characteristics are working.
Thank you.
Yes.
My next question is for the reporter. You mentioned that you use coin sets of different coins glued together.
$1 coin.
Yes. So I would like to point out that by doing this, you would make the side uneven. Do you think this would affect the results?
Side I think just the two and is parallel that is within.
But the surface would be uneven. Do you think that would affect the bouncing or the rolling of the dice?
Maybe a little.
Okay, thank you. My next question. You mentioned that the collision when the dice hit the ground would be an elastic collision.
Yes.
So in your simulation, did you consider deformation?
Deformation. In theory, didn't.
Oh, okay, thank you. My next question is for the opponent. How do you think the results would change if, in real life, the dice was a rigid body?
I think if it is in a rigid body, then you won't have to consider deformation, because that's a big part of their experiment. Because
I mean, how do you think it would affect the results?
So it will basically follow their theoretical value, because their theoretical value is predicted based on the fact that it is a rigid body.
Okay, thank you. That concludes our discussion.
Okay, the start of the presentation of the reviewer.
Okay, so I'm the reviewer today from Team Type C, and the problem today is three-sided dice. So the opponent on the side is often associated with the idea of a rare occurrence, which should be the physical and geometrical characteristics of a cylindrical dice so that it has the same probability to land on its side and one of its faces. Here's my summary of the reporter's report. For the phenomenon, they described that the dice would fall on the table and would lay on the face or the side of the dice. And for the theory, they discussed the curved surface area theory, in which they believe that the curved area that the dice landed on would be the corresponding result. And they also used the tip-over correction. And for their setup, they used dice models including coins stuck together into a cylinder, and as well as copper sticks. And for their variables, they changed the thickness of the dice. And the dependent variable would obviously be the probability of different results. And here's my summary and comment of the discussion between the reporter and the opponent. The opponent asked, have you considered friction in this experiment? And the reporter believes that it would affect the results. However, while this is correct, I believe that the reporter should conduct some experiments discussing this point instead of simply theorizing. Next, the opponent asked, what is the difference between the experimental condition and their expectations? And the reporter explained that in the theory, the surface is a rigid body, and in reality, it would be closer to that. Well, not exactly on point. And next, the opponent asked, how come there is such a great agreement between your experiment and the theory, since some of the parameters were not actually considered in the theory? And I think this is actually a really good question from the opponent, since it doesn't really make sense that their results would be so matching to their theory if many parameters such as friction were not, or deformation were not considered. And next, the opponent asked, how did you make the dice used in the experiment? And the reporter explained that they stuck coins together using glue. Next is my discussion between me and the reporter as well as the opponent, and I asked the opponent what they meant by constant probability, since so many parameters that were at work, and there wouldn't necessarily be a constant probability for different initial conditions. And the opponent explained that they simply meant that there should be a certain range for the different parameters. For example, the coefficient of friction could not be too low or too high. And I think the opponent makes a great point. However, I think they should term constant probability more accurately. Next, I asked the reporter whether or not they considered deformation in the simulation, and they said no, they did not. And I believe in the future they can add this parameter into their simulations, and perhaps they will have some great findings. And also, I asked the opponent how would the results change if the dice were a rigid body, and they believe that since in the theory they already theorized that the dice would be a rigid body, then the results would fit even more if the dice were a rigid body in reality. And here are my comments for the opponent and the reporter. For the reporter, the advantages is a large amount of equations, fluent presentation of the theory, and as well as they use simulation. And for my suggestions, I would suggest that they use some demonstration videos, as well as add some of the physical characteristics into their discussion. And for the opponent, I would like to point out that they made some great points. They pointed out the flaws in the reporter's report very accurately, and had a fluid discussion with the reporter. And finally, I would like to point out that one of the hugest missed points was that the physical characteristics should be discussed as well, and this was pointed out by the opponent.
Okay, and the conclusion result.
condition because I just assumed our initial condition and in our experiment as random by shaking it in the pot. But in the reality, there isn't really a random condition. So there must be a lot of the parameters to affect the result, like the coefficient of restitution or the mass of the dice. If the mass is too small, it might be affected by the air resistance and the deviation of the fluid. I think it might affect the result. But there, if we do just in the fluid, it still has some deviation. So that there didn't have a really rigid fluid. And according to the opponent and reverse suggestion, I think I can do more parameters in my experiment in the future. And in my report, I think the geometrical characteristics is the thickness to the diameter ratio in my calculation. And the physical characteristics, I just mainly focus on the potential energy and due to the height of the center of the mass in my theory. And that's all my conclusion. Thank you.
Okay. And any question from the jury?
这样子，short question. If you throw on the floor, a concrete floor, do you think the ratio 0.47 will give you the same answer? I'm sorry.
Can you repeat
Oh. If you throw your cylinder on a concrete surface, what would you expect the probability? If you use the best ratio, 0.407, then yeah, 0.047 will you get a third for the side?
I think the probability of the new answer might be bigger than my experiment value.
Why?
Because this surface qualified. And here the formation here, the forest given that might not be uniform. And sorry. So in this condition, it might just get this side and more on the side. But about that, if the floor is very high, it might have this deviation. Like the chamfer of the coin, this surface would contribute to this probability.
A question for Conan first. So you mentioned that the reporter didn't consider too many physical conditions, and so you also mentioned that maybe some physical conditions, including mass and the initial velocity and so on, very important. But I think you think that's really very important, or?
Okay. So for the mass and the initial velocity you just mentioned, it is for the parameter. So for physical characteristics, I believe it's the most important thing has to do with potential energy. So we all know that when a dice is the potential energy needed for this dice to stand upright is the largest when you compare it to landing on the side. So the potential, if the potential energy is larger, then it means that when the probability will differ a lot, because this will definitely not follow the geometric characteristics as you need more potential energy. This is what their theoretical data couldn't provide. So for a physical one, you will have to take it into considerations, like for example, deformation, because the normal force will differ a lot because you don't know where the contacting point with the surface is. So it might be here, it might be here, it might be here. So that's why the normal force will be hard to determine. So that's one of the physical characteristics that they should consider. And the second one, I believe, is the potential energy.
So this is the most important physical character is potential energy.
Yes, I believe.
So how do you think?
Yeah, in my theory, I just think like the
I think as a chief consider
yes.
potential energy. But do you think is there any other important parameter?
Yes, I think there must be many parameters in the reality. Like
Which one is most important you think?
most interesting.
Yeah, because
I think under usual circumstances, it will be the potential energy. But for their case, because they're sticking copper coins together, which means that every copper coin has different mass. So their coefficient of friction will definitely differ from one dice to another, because if they use an older coin to construct this dice, then their coefficient of friction will be lower. But if they use a newer dice, their coefficient of friction will be definitely higher. So in their case, physical characteristics that might be the most important might be the coefficient of friction. Yes.
And I want to continue about the opponent C. And if C, the coins might not be uniform and might not be symmetry. But in my experiment, I also use the copper stick, the uniform copper stick, to do the experiment. The trend is the same, and the variation between the copper stick and the coin might be the chamfer factor, or a little might be the unsymmetry. But go back to Professor's question. I think in general reality, there is much parameter also is very important, and because many parameters like the deformation or the initial velocity, the initial condition, the releasing height, or the mass could really affect the result. But in our theory, we calculated the geometrical characteristics and plus the physical characteristics explanation of the potential energy. We can found the result of the dice landing on the site in the ideal condition in our theory. But in the reality, that really and is in the random condition, like the Palestinian see the rare occurrence. So I think that I can do more parameters in my experiment in the future to investigate.
I think the reason that physical characteristics are important in this question is because cylindrical dice are not, the different faces of the cylindrical dice are not actually identical, unlike with cubical dice. And therefore, perhaps like the faces or the size would not have the same properties, and therefore a lot of physical parameters would affect the results a lot. And I think some of the most important physical parameters include the horizontal velocity at the beginning, and the friction, as well as the bounciness of the dice.
The score for the reporter: 5, 6, 9, 8, 6. And the score for the opponent 7, 7, 6, 8, 8.
Thank you.
And for the reviewers 6, 8, 8, 8, 8. Okay. And thanks for you joining this competition. Okay. The morning session is ended. Yes.